Namaste to all. This is JV and Dr. Vishal Saxena, Professor in Mathematics, JAYOTI VIDYAPEETH Women's University, Jaipur. I'm going to take a lecture on the topic of Runge Kutta method, and this topic belongs to the course of BSc B.Ed 8th semester and as well as BSc 8th semester, running in the program, running the running the Faculty of Education Methodology. So today's topic just belongs to the subject of numerical analysis, and this is under the course of complex and the numerical analysis of this program. So first we have to understand what is Runge Kutta method. Actually, Runge Kutta method is a numerical method. As all we know that there are certain different numerical methods for solving the differential equations of ordinary and as well as the partial differential equations. So this Runge Kutta method is also a very good method, is one of the best method among the different methods, and because it gives the accurate solution for the differential equation, and the other different methods like the Euler's method and the different methods as well, like the Picard's method, Millen's predictor character method. These are not giving so accurate solutions as this method. So this Runge Kutta method is also a very important method for the research purpose, because ultimately when a problem of differential equation in the case of ordinary or the partial differential equations, and as well as in the case of the coupled differential equations, then this method is a very good one, and this method can also be used with the shooting method and with the computational softwares to solve the various problems. So just today we have to understand what is this method. And suppose we have a problem of differential equation. That one is the first order differential equation, dy by dx is equal to fxy. So this is a first order differential equation, and we are given that suppose the boundary condition that is y at x naught equal to y naught. So means at the beginning point at x equal to x naught, suppose the value of y is assumed to be y naught. Therefore, x is the independent variable and y is the dependent variable of x. So what is this Runge Kutta method? In the Runge Kutta method, there are certain steps to find, and then finally we can use a formula to find its value of solution and its answer value. So initially we have to find the K1 term, the term of K1. Next is K2, then K3 and K4. So what is meaning of K1? The meaning of K1 is equal to h into function f xn comma yn. Here we are taking general value xn and yn, means suppose here just we are discussing about the nth value of x and the y, and h is the width of the class interval that is taken here for the variable x, which is independent, and f is the function that is equal to dy by dx. So K1 is equal to h into function f xn comma yn. Next, we have to find the value of K2. K2 is just given by h into function f xn plus h by 2 comma yn plus K1 by 2. So ultimately in the previous value we have increased here xn by h by 2, and the yn is increased by K1 by 2. So K1 just we have already calculated in the last step, and in this way we have to calculate our K2. Next K3. K3 is given by h into function f xn plus h by 2 comma yn plus K2 by 2. So again just we can see there this h which is the width of the class interval, and function f, f means this is the differential equation. dy by dx term, and the xn is again increased by h by 2 again in this term, and yn is increased by k2 by 2. So just after finding k1, k2 and k3 in this way, next we have to calculate k4. K4 is given by h into function f, xn plus h and yn plus k3 term. So in this step, just as we can see in the last steps, there is some difference, and xn is increased by h and yn is increased by k3. So this K4 means K1, K2, K1, K2, K3, and K4. These are the successive terms, and we have to find these terms for every step. So this K4 is given by h into function f, xn plus h, comma yn plus k3. So just by finding K1, K2, K3, and K4, finally we are having a formula for the solution y. Y means the solution in terms of the dependent variable y, and its n plus 1h value is given by, so yn plus 1 is given by yn plus k1 by 6 plus k2 by 3 plus k3 by 3 and plus k4 by 6. So this is again I'm just telling this one here, yn plus k1 by 6 plus k2 by 3 and plus k3 by 3 and plus k4 by 6. Sometimes it is written in a different manner. So like yn plus 1 is equal to yn plus it is 1 by 6, then k1 plus twice of k2 and plus twice of k3 and plus K4. So these are the two different ways to write this formula, and plus order of H5. So this shows the error term, and just we have discussed already. I have told this already. This method is a very good one, and this is quite applicable for the differential equations because it is approximated to give the correct value as compared to other methods. So this is the method of Runge Kutta. Now we take one example to understand what is this method is. So suppose we are having a differential equation, and this is dy by dx is equal to x square plus y square. Dy by dx equal to x square plus y square when y1 is equal to 1.2, and it means the initial value of x is given that 1, so that is taken as x naught, and the value of y, initial value of y, that is taken as y naught, and this is 1.2. So this question is here using the fourth order Runge Kutta method, we have to find the value of y at x equal to 1.05. So this method, Runge Kutta fourth order method, is to be used, and just we have discussed already this method. Runge Kutta fourth order method is a very good one method, and we are having also some different methods of Runge Kutta like the second order method, fourth order method, and the sixth order method. But the most like common method, that one is Runge Kutta fourth order method. So initially, just we see how to solve this question, how to solve this differential equation along with the boundary conditions. So first we can see dy by dx means it is equal to fxy. So therefore fxy is given that x square plus y square, and we can see this one fxy equal to x square plus y square, and x naught equal to 1 while y naught equal to 1.2. So it is 1 and 1.2, and h is taken as a 1.0, h is taken as 0.05. The value of h depends upon us. We can take whatever the value h, but this is to know here the if h is very small, then definitely the solution will become more accurate, will become good one, and therefore h is taken as here 0.05 because we have to find the value of y is equal to 1.05. The other h can also be taken, and therefore just h is taken as 0.05, And now we will find the four different terms value like K1, K2, K3 and K4. As already we have discussed in the method in the this algorithm how to find K1. So K1 is given by h into function f x naught comma y naught. X naught and y naught are the initial values for the function, and therefore just we are given that x naught is 1 and y naught is given that 1.2. H is given here 0.05, that is not given, that is we have assumed. So 0.05 is the value of H and therefore K1 becomes here 0.122. So this is K1. Next, what is K2 there? K2 is there H into function f x naught plus h by 2. One important thing that we should use the scientific calculator to calculate this value of K1, and the whole equation should be right in the simple way. The complete equation should be written there, and instead of the calculations of different terms, so we will get the correct value, and K1 is coming there 0.122. Next is the value of K2. K2 is given by h into function f x naught plus h by 2 and comma y naught plus K1 by 2. So h is 0.05 and function. What is function? Function is our the differential equation, the derivative term dy by dx, and therefore it is a function f and x naught and h by 2. X naught is given that 1 and h by 2 h because it is taken as 0.05. So finally x naught plus h by 2 becomes 1.025, and y naught plus k1 by 2. Y naught is already given that we are 1.2 and k1 we have already calculated it. It is 0.122. 0.122. So therefore it is a 0.05 and function f and then 1.025 comma 1.261. And when we solve it here using our our scientific calculator, then we will get its value as 0.1320. So in this way, I think it is quite clear. It is not a very good, not a tough one method. It is easy method. So initially we have to find K1, K2, K3 and K4, and then we have to find the value of Y according to this here. So K3 is given by h into function f x naught plus h by 2 comma y naught plus k2 by 2. This is already just we have discussed, and now we have to put the various values. So this h is 0.05 function f, and then what is x naught plus h by 2? X naught is 1 there, and h by 2 means h is there 0.05. So it is written, it is already calculated. What is h by 2? It is 0.025 comma 1.2 means it is y naught, and plus k2 by 2. So K2 by 2 means that is just we have already calculated. K2 is already calculated just in the last step. So it becomes 0.066. And therefore, on solving this term, we are getting, we will get there 0.1326, that is K3. Next is K4. K4 is in a similar way. For the K4, we are having a formula h into function f x naught plus h comma y naught plus K3, and h means here 0.05 function f, then x naught is 1, h is 0.05, y naught is 1.2, K3 is already we have calculated 0.1326, and in this way what is coming there, it is 0.05 into function f 1.05 comma 1.3326. And in this way just now we have to expand this function f as given. So f is given here x square plus y square, so it means 1.05 square plus 1.3326 square, and that is 0.05. So it becomes a 0.1439. When we solve this term, when we solve this term, K4 becomes 0.1439. So in this way, in every question, first we have to find K1, K2, K3 and K4, and then a term of K, which is capital K, can be given here. Just I have uh, told here this in this way. K means 1 upon 6 into K1 plus 2 K2 plus 2 K3 plus K4. It is not written there, but some books the K is also defined in terms, and the solution yn plus 1 is equal to yn plus k. So K means 1 by 6 K1 plus 2 K2 plus 2 K3 and plus K4. So finally, this Yn plus 1 is equal to Yn and plus K, and K just I have explained what is K means here. So because we have taken here H as 0.05 and therefore we have to see what is X naught there. We have taken as X naught as 1, and therefore just we can see therefore x1 becomes 1.05. So corresponding to this 1.05, we have to find the value of y. So it means y at 1.05 is given by, that is y1. Y1 means because yn plus 1, and initially we have to put n equal to 0. So it means y1 becomes yn plus 1 becomes y1, and y1 becomes y0 plus 1 upon 6 k1 plus 2 k2 plus 2 k3 plus k4. And therefore when we will put these values, so we can see there y1 becomes y at 1.05, and now put the values, and this will become finally 1.3325. So this is the y means the solution at 1.05, and this is named as y1. Y1 means at corresponding to x1. In a similar way, if we have to find y2, y3, y4, other terms, then again a loop can be like taken, and where in every step, in every loop, where just we have to find these four terms of k, like k1, k2, k3, k1, k2, k3 and k4, and then we have to find k means 1 upon 6 k1 plus 2 k2 plus 2 k3 plus k4, and therefore y in yn plus 1, put n equal to 0, then we will get y1. If we will put here yn equal to 1, then we will find the y2. If we put here n equal to 2, then we will find y3, and in this way we can find the other values. So this is called the Runge method, and Runge method is a very important method for the different classes, for the different courses, different programs. So actually this is a part of the solution for the numerical, for the differential equations, and like we can see this one, this is also a very important part of the various differential equations, like simple equations, ordinary equations, and the partial differential equations, as well as the high order non-linear differential equations in non-coupled form and the coupled form. We can solve these equations. We can solve the equations along with the different methods as well, like the shooting method. And so this is a important method, and this method gives a very accurate solution. So this method should be used for the differential equations. So with this, I am concluding my today's lecture. Thank you.